question here says, what's the probability that the fair die shows a 6 and the biased die doesn't show a 6? So here's the biased die. The biased die doesn't show a 6 and the fair die does show a 6. So we're going to multiply along these branches and do 3/4 multiplied by 1/6. I can cancel there 1 and 2, and the probability there is 1/8. Okay, part B says, what's the probability that at least one of the two dice shows a 6? Now, the easiest way to do that, effectively, one of the two dice showing a 6 means you could have 2 6s, or a 6 and not a 6, or a not 6 and a 6, which means that the only thing that they're not requiring there is this one. So the easiest way to do that is to do 1 minus the probability of not getting a 6 on both dice. In other words, I'm going to do 1 minus 3/4 multiplied by 5/6, which is 1 minus, I can cancel there 1 and 2, so it's 1 minus 5/8, which comes out as 3/8. Now for the last part here, I'm going to use my identity, which is that the probability of A, given that B has happened, is always equal to the probability of A and B both happening divided by the probability of just B happening. In other words, in this case, and you have to look at the wording here, the question says, what's the probability that you have exactly 1/6 given that at least one of the dice is a 6? In other words, given that there is at least 1/6. So if I continue writing that in words, this is effectively my A, this is my B. So I want then the probability of getting exactly 1/6 and at least 1/6, and I'll explain how to get that in a minute, and at least 1/6 divided by the probability of the second one there, which is the probability of getting at least 1/6. So how do I do that? Well, it's the top that's a little bit tricky to understand here, because how can that be? You're still throwing 2 dice. What's the probability with your 2 dice that you get exactly 1/6 and at least 1/6? Well, effectively, the exactly 1/6 rules, if you like, there. Getting exactly 1/6 and getting at least 1/6. Well, the only way that you can get that to happen is by getting exactly 1/6. So it just becomes the probability of getting exactly 1/6 divided by the probability of at least 1/6. So at least 1/6. Now let's have a look at how that happens. The probability of getting exactly 1/6, if I just look through my tree branches, the probability of getting exactly 1/6, well, that means going this route, so getting a 6 and not a 6, or going this route and getting a non-6 followed by a 6. So I'm going to do both of those. So first of all, 1/4 times 5/6. So I'm going to do these two multiplied together. So that's 1/4 multiplied by 5/6. And I'm going to add, because we've got the OR situation, these two. So 3/4 multiplied by 1/6. So this is going to 1/6, which is going to be my top probability. And on the bottom there, in part B, I've already calculated the probability of getting at least 1/6. That's my answer to part B. In other words, my 3/8 up there. I've obliterated it. There it is, 3/8. Okay, so let's just keep going. It's just a bit of fiddling around with fractions now. Well, 1/4 times 5/6, well, that's 5/24, plus over here 3/24, and that's divided by 3/8. So we've got 5/24 plus 3/24, well, that's 8/24 divided by 3/8. In other words, well, I can cancel that to a third. So it's 1/3 divided by 3/8. Well, that's the same as 1/3 multiplied by 8/3, which comes out as 8/9.